When most teams start building AI applications, they pick a model provider. OpenAI, Anthropic, Google, whichever one fits their use case at that time, they wire their application directly to that model's API. This works fine till the application is simple, but as soon as the complexity and requirements evolve, the direct model integration begins to create challenges. The first challenge is with vendor lock in. The moment you tightly couple your application to a single provider, you've basically made a bet. If that provider raises prices, has an outage, or simply isn't the best model for the new task that you're trying to implement, you are stuck with that model. Switching becomes a full engineering effort and not just a configuration change. Every provider has a different pricing model, different token costs, different rate limits, different quota tiers. Optimizing spend across different model providers from within one application is not just difficult, it is nearly impossible without unified layer to reason about it. Outages happen, rate limits get hit, and regional availability varies for a model provider. When your application directly talks to only one provider, any disruption on their end becomes a disruption for your users. There is no fallback or retry logic across alternatives. With different teams spinning up their own AI applications with their own API keys, their own provider accounts, their own contracts, what you have is scattered credentials, inconsistent policies, and zero centralized visibility. This is a governance and compliance nightmare waiting to happen. And additionally, every provider has its own SDK, its own request format, and its own response schema. Maintaining multiple integrations within the code means multiple set of bugs, multiple upgrade cycles, and cognitive overhead that slows down the engineering team. And this is where LLM Router can help. LLM Router sits between an application and model providers. Applications no longer need to know whether the request goes to OpenAI, Anthropic, Google, or any other provider. They simply talk to the router. The router evaluates the request and determines which model best meets the requirements based on factors such as cost, quality expectations, your latency targets, user policies, and provider's health or availability. LLM Router can centralize the enforcement of policies such as authentication, rate limits, content filtering, and PII masking. It can also centrally capture telemetry for observability and can perform caching for frequent requests and retries in case of model failure. The key idea here is that LLM Router acts as an abstraction layer, centralizing the management of multiple providers behind the scenes. Once you introduce the router, the next question becomes, how does the router decide which model to use for a request? The simplest approach is to use a rule-based routing, where you have predefined policies to determine the destination. For example, for summarized requests, use GPT-4o Mini. For premium tenant, use Claude 3.5, etc. These policies are defined at the design time. Capability based routing is more dynamic in nature. Here, the LLM router inspects the incoming request for its capability requirements and chooses the right model based on that. For example, if the request requires a vision output, then LLM router can route it to a vision model. If it requires a model that supports long context, then it can dynamically choose the model that provides that context length. Cost-aware routing inspects the incoming request and its complexity and uses the premium models for tasks that truly require them. If the incoming request involves complex analysis, it can use a bigger model, whereas if the request is a simple FAQ, then it can choose an economy or smaller model, which is cheaper. Fallback routing focuses on maintaining resilience of the application. When a provider fails, it can implement either retries or fallback mechanisms. Latency-aware routing optimizes responsiveness of the model by choosing the fastest available option. For example, for a request that originates in Europe, it may choose the model that is deployed in Europe. And in reality, these are not competing strategies. Most production systems evolve towards hybrid routing by combining policies, capabilities, cost, latency, and availability to make the best decision for each request. Let us see how an LLM router can help with optimizing cost of an AI application. Routers can help implement model tiering by matching model capability to the business value. For applications that implement complex workflows, the requests can be routed to premium models, whereas applications that implement routine requests can leverage faster and cheaper alternatives. Dynamic model selection evaluates each request in real time to understand its requirements and then choose the most cost effective model to support that request. For example, a simple FAQ cannot be treated the same as a financial analysis. LLM routers can also implement caching to avoid repeated model calls for common requests. Failures are inevitable in production systems. Providers experience outages, regional disruptions, rate limits, and latency spikes. The router shields an application from this complexity. If the primary model is healthy, the requests follow through the normal path. But when the issues occur, the router applies resilience patterns such as timeouts and retries to recover from transient failures, circuit breakers to temporarily stop routing traffic to unhealthy providers. The router can also try another region, fail over to another provider, or provide a degraded response by using cached content. The important point here is that we move the resilience patterns to the LLM router, and individual applications do not need to implement these mechanisms themselves. In many enterprises, router's most valuable role is not routing, it is governance. Because every request flows through a central point, the organizations can consistently enforce authentication, authorization, rate limits, content policies, and PII protection. They can also implement centralized audit logs and resilience mechanisms such as retries, fallbacks, health checks, and load balancing. Rather than embedding these controls into every application, the organization can centralize them using an LLM router. LLM routers can be deployed in several different ways depending upon the organization's priorities. You can self host an LLM router to maximize control and privacy, but this requires additional operational ownership. Managed cloud solutions can accelerate adoption by offloading the operational overhead and infrastructure management. Hybrid approach keeps the sensitive workloads private, whereas uses cloud for everything else. Edge and multi-region deployments can reduce latency and support data residency requirements. The right choice here depends upon the priority. If the priority is control, then self-hosting is the best option. If priority is speed, then managed clouds can be considered. In case you need flexibility of both control and speed for different workloads, you can have a hybrid implementation. And for global reach, edge or multi region implementation can be a good option. The ecosystem of LLM routers has matured considerably, and there are several strong options today. The screen provides only a subset of such options. Light LLM is quite popular with teams that value open source, flexibility, and self hosting. Open Router provides simple access to hundreds of models through a unified API. Port Key focuses on enterprise capabilities such as observability, evaluations, and governance. Cloud native gateways integrate naturally with major cloud providers such as AWS, Azure, or Google Cloud. And let us see an example agent workflow that implements LLM router. So here we have a planner agent that decides what needs to be done by breaking the goal into smaller steps. The execution agent carries out these steps. And for each step, the LLM router decides which model is the most appropriate. Depending upon the request attributes, one step may prioritize speed and cost, another one deep reasoning, and another one long context processing. After each model call, the control returns to the execution agent. Execution agent evaluates the result and decides whether more work needs to be done. The router can make a different model call even for the same request each time it goes through the loop depending upon how it changes. Using the LLM router, a single user request may involve several models that are working together behind the scenes. One mistake that teams make is assuming that they need LLM router from day one. The reality is that it's an architectural tool and it's designed to solve specific problems. If you're using multiple providers, you need resilience, centralized governance, cost optimization, or sophisticated agent workflows. A router provides substantial value. But if you're building a prototype, a small internal tool, or a simple application that relies on only one model, then direct integration is often a better choice. In most enterprise use cases, the question isn't whether everybody should use LLM router. The real question is at what point does the complexity of your AI system justifies introducing an LLM router?